Hello guys, this is a little bit of sperging video. Like, actually, someone is wrong on the internet, sort of. I have seen this. I've seen this again, and I was sperging here. This was a presentation on of what would happen on the Sega Saturn if we saw what's really happening behind the hardware, and that the Sega Saturn and also the 3DO they are similar in some ways with their quad rasterize, that they were using 2D sprites to render 3D. And this is a very characteristic video that became viral in a way and blew their mind when Digital Foundry was showing that okay, you have Tomb Raider working on this 3D environment. Here you even see the mess. It's an actual 3D engine. It's not what it, but somehow to fill this polygon, it has to stretch, warp. It says warp those sprites in their original form. If you stop things in the hardware from happening in an emulator, for example, if you cancel the additional transformation that need to happen to stretch the original bitmaps, you might get this one. And everybody was like, oh my god, I can't believe how horrible Sega was with, what was Sega thinking? How could people program this? You had to start from some crazy soup of 2D sprites with a 2D engine and somehow warp them to create 3D. So warp this one to this one to create 3D. What the hell? But this is misleading. This always bothers me since the inception, and I see this repeated. And a lot of comments were seeing this and agree, oh my god, yeah, that's horrible. It's horrible that. How did people work in the Sega Saturn or the 3DO too? Because it's similar on the 3DO. How did people? That explains it. Why I always wonder why the Saturn version fell off. That explains. Oh my god, that explains everything. Incredible. So how does it apply the story to create the illusion of 3D? I mean, this is no different in most aspects. This is not different than a regular 3D engine. You see even here, when you show the wireframe, it is actual polygonal engine. What does, I was searching for something here, I can't easily find. Maybe I should do, I was searching various things to find some good, I didn't have time to do my own. And most of you might have seen how 3D engines work. You start from a 3D scene. Okay. Those might be object meshes made from vertices connecting triangles, and you rotate them in 3D space. You do the 3D space transformation in the data. There is no rendering yet. There is no rendering. And when you reach the final part of the pipeline, when the final 3D points are projected into a 2D screen. And now you have 2D points projected in the screen. You know the triangles. How to say? You do the 3D transformation in the final point of any regular 3D engine. You know now that, okay, I have to. Why? Okay, I have to find the right shape now. You know, maybe a quad, okay. You know that I have to map to some polygon. This is in a regular, this is the final step. Final step of 3D engine. map bitmap polygon. Okay, this is a ortho. Okay, in the PlayStation you have triangles, so you have to map two triangles. But you have to map an original bitmap there. You have to map those points there. Of course, these points are given as you follow. You have 3D vertices. You might do the transformation on the CPU. You might do on the hardware. In fact, the 3DO has a hardware matrix multiplication. But then you need to do the projections on the CPU to the 2D. You do that, okay, some of them are on the OpenGL or something on the GPU with the vertex processing fragment. It has to do with shader. But finally you have your vertices mapped in 2D. And in that final step, the 3D or the Saturn comes and maps those polygons. And if you remove that mapping, you get this. Because here is my Bizarro engine. Let's see. See, that's annoying. I think it's conceptually, this is the final step of a regular renderer. And the Saturn 3DO it does things a bit different. It takes a complete bitmap and maps it in the quad instead of a triangle. And it's also a forward renderer. I will explain. So that's my engine. I'm doing 3D point transformation a bit on the hardware, a bit on the CPU. I project the points on the CPU with a division that is really a lookup table reciprocal multiplication to avoid division. I use lookup tables. And now I have points I have projected points here. So I will take this bitmap, which is in its original form, and map it to fit. And that's it. There is nothing magical. There is nothing, I'm reading some this whole thing was since if you don't know, it's misleading because people think, oh my god, so the whole environment was done like this. This is crazy. People think there are some zooming 2D sprites like Doom, billboards that were somehow mapping the whole thing. And you could say it kinda is, but I will speak about it. So people, I'm not. I mean, if all these people have know how a 3D engine works, I want to tell you, this is just the final step. This is the final step where you map an arbitrary bitmap, or okay, on PlayStation you have triangles, and it's a reverse rasterize. The only difference is that the 3DO and the Saturn will do a forward render. It will read every. It really is stretching a sprite, but that's to map an arbitrary polygon area. The 3D calculation has done before. You're just filling an area. You're doing texture mapping in an area in the image space, and that's it. It's not like you use zooming sprite to create a 3D environment. It's not so different than doing the transformation of the PlayStation and doing a reverse rendering. Now I don't have the polygons, I just have some floor. It could be a triangle in the case of the PlayStation, going through. I should have prepared for that. Through scanline per scanline and read back from the texture. Okay, I have to fill those triangles. I have to fill these screen areas. From which texture pixels to go? That's the difference. The 3DO does it like this, but it's the same. It's just that step. And to me, it's also that step. It says 3D progress. It says 3D because In modern hardware, the Z value is interpolated, but it doesn't matter because you are in screen space at this point. The Z value is interpolated to have the Z buffering and perspective correct mapping. It could be even misleading that it's some information in 3D, but the pixels are 2D here. Anyway, and I was explaining even here. The only difference is that the 3DO is going to use, instead of points at the final step, it's going to use 3 vector, 1, 2, and the third one that will allow you to map any arbitrary polygon. You might have to, but it's not. I even seen. Okay, there was a comment that said, drew 2D sprites for environment and distort them in 3D space. That's not true. It distorted the 2D sprites in the polygon areas that are still projected in 2D. It's doing everything a regular 3D engine does, and in the final step it has to map the original bitmap to interpolate them in the final area. And here, for example, you have seen my engine. It's a bit, I mean, okay, it's a bit misleading, but fine. But most people take it like, I hope now that this works, take it like there is something bizarre, that it's a very unorthodox, a very hard way to do 3D engine, because most people think I just take this soup and somehow make them 3D, this soup of sprites. But that's not. You have done, I'm repeating, you have done. There is already a 3D engine here. You see the wireframe. You just have to cover this polygon that is now stretched. It's not in its original square form. You have to stretch the. I guess I know in the PlayStation you give the 3D point. It's going to be 2 triangles. And it has texture coordinated interpolate, but it interpolates the texture in the 2D image space. On the 3DO, you do the forward rendering where you get a bitmap and stretch it to fit this area, which is very simple, okay? And you have to do a bit of additional work with calculating from the 4 quad points to the vector that it needs to fit to, needs to stretch it. But it's not. Again, people think, and I see people asking like, how do you go from this one to 3D? No, you don't go. You have already projected the polygons. You have done the 3D and you have the projected 2D polygons. I say that many times. And here it is. Here is my engine, how it looks, doing the same exact. And what did I do? I just cancel those transformations. This is not hard, this is a regular 3D engine. Okay. This is a regular 3D engine where I didn't do the work to fill the correct. So I see the original sprite, but what I'm seeing, if I was on the PlayStation, I would be seeing the original texture. Also on the PlayStation, you pass vertices, you don't pass. But these surfaces are pointing to textures. I'm not taking this thing and it is like I'm taking those sprites and mapping them. But it's hard to explain. It's misleading. It's misleading because this is the final. Till this point. Okay, this is not the right. I can't find a good one. You do all the 3D transformation thing, and you end up with 3D points projected to the 2D space. Now they are 2D. And you know which pixel areas to fill. You know that I have to fill this pixel, and this has to be stretched and mapped here. And that's it. It's the final step. The only extra thing is that the 3DO, I don't know about the Saturn, doesn't take the 4 quad points. It will take 3 vectors that will tell how to map the, and this is a standard thing. And here, see, I was doing the work in this one for those vectors. You see HD, Y, VDX. This is the starting position. I haven't erased that one. In fact, if you are to also put this to 0, it's not as dramatic. So, I was doing work to map. Those are the 0.0123 quad 0123 x, y. I get them from screen elements. This is a struct that might be holding more stuff. I have an engine that does visibility. I have matrices. I'm even using, if you use the functions translate and project versions, vertices. Okay, these are functions of the 3DO API that takes a matrix and your vertices. These are 3D vertices, and I transform them, and I go through other things, and I project it. And when I project it, I get the X, Y. For some reason, I keep the Z, even if. But it's those two, and now, and these are the 4 quads. And unfortunately, the 3DO hardware doesn't take those quads, which are in 2D now. Okay, it's going to fill a 2D quad area on the screen. Okay, on PlayStation it's triangles and it's reverse rendering. Here it's quad, it's forward rendering. The only bad thing with the 3DO, there are no texture coordinates. It has to fill the entire texture on the screen. So if you want to do clipping, you have other problems. So yes, the Saturn and the 3DO have trouble, although it's not that harder compared to the PlayStation 1. They're not as good for 3D stuff, although people have done some really good stuff. They are not as direct and easy, but the only thing is you have to do this extra step, which takes a bit of time, but not much. Mainly this one, based on the points to create the vectors, some mathematics here, and I have cancelled them. That's what I have done. I have cancelled them, and now, okay, you see nothing because the positions are at 0. I thought I would see them here. You will see all the textures here. That's what I thought. Okay, but maybe there is a black texture that over. So that's not a good example. And for example, if I decide to say, okay, I'm not going. Look what I'm going to gradually. Okay, let's restore those vectors, but I don't restore these vectors. Let's do that. So to me, it's absolutely fine, and it's misleading because all you did is you had a complete 3D engine that did things that it's not much. It's very, very close to what you would do today. You just have to give the vectors to stress the texture to match and not the opposite. Now, see. You see it now. You need the third vector. If I look straight, it's doing that, and it's shearing because it doesn't correct the third vector. That's kind of trippy, actually. But why? Because I manipulated. People say, oh yeah, that proves that it's sprites. I mean, okay. I get you. It's kind of like but it's the final mapping. It's the final mapping in the 2D space after the 3D engine has done everything that it has done in a regular way. It's not some magical, obscure and unorthodox way that is so hard to program. It's so hard. Oh my god, I have to start from this. So people see that and say, how the hell do you take that random chaos of 2D sprites and you make? People think this is something like Outrun, you know. And some of the Sega hardware had this, but zooming sprite, but it was different. Here is that you can map an arbitrary bitmap any way you want, and that's what you will do in the final step of an engine. And of course, okay, it's going to be some affine linear texture mapping, although in the 3D it's not as affine, but for us other reason there is it gradually changes. You see, it's linear here, but it's stopped vertically. The vector changes. On PlayStation, something interesting would happen. If you have a diagonal here, all the vectors in this triangle will be the same, and suddenly they would change. So you would have two triangles with different interpolation constants, and you would have a seam in the diagonal. That's why you would see perspective correct errors that are a bit different than what you will see in 3DO. You will have them here too, but in a different way. Yeah, it's hard to explain. It's because you see in the original there is an actual 3D engine. 95% of the thing is no different than a typical rasterization pipeline, and it's all about how to map those final bitmaps, texture and position. On the PlayStation 1 and modern engine, you have the same thing. I mean, you would think a 3D effects would do. Okay, that's the 3D effects would do, or something. No, Diamond Multimedia 3D effects. Let's see. You think? Can I get the screenshot? Do you remember the early from Tomb Raider, Quake 2? You would think the 3D effects would do is definitely 3D, whatever that means. I mean, it is even more because it has perspective correct Z buffer and so on, and also does nice filtering, but it's not the case. But from what I remember, those early cards were only providing the rasterizer. They were only providing this part, maybe. Now this is from a set. They would provide the final render, and they would prefer this part in a way, but not like this. Okay, not like this. This is not how it's done. But they would provide the method to take one square or non-square, one rectangular texture, and map them in any arbitrary. And okay, add that it was also on triangles and it had texture coordinates. But still, this is the final part. That's what I'm thinking. You see the final part of a whole engine that looked like this, and then someone went and destroyed this code. These are the default values to cancel the whole stretching I'm doing. So it destroyed the code in the final part. It went backwards. It was rendering this thing. It was doing everything a normal engine does. Just mapping with quads and presents this or this. And people are like, oh, I have to go from this to a 3D engine somehow. How does this even work? What a perverted way to do 3D graphics. But this is wrong. Okay, this is the misleading thing. I see a lot of comments say, "Oh, that explains it all. That's why it was so hard to make." No, it was hard on the Saturn on the 3DO because there were no texture coordinates. You always have a bitmap that was there. There was forward render. There are other problems, and also most 3D models in the games, most 3D modelers would do stuff with triangles. So if you were to port a game from PC or PlayStation 1, you would have to reconvert the triangular meshes to quads. So you would have other kinds of problems. Now, if a PlayStation gets a game from 3DO, or they will just render the quad with two triangles, and that's it. They will subdivide. And actually, the PlayStation might have it could render one quad, but it will split it internally into triangles from what they say. The other thing with the PlayStation, must have a more unified hardware from what I hear. Like you pass the triangle, they are transformed in the hardware, and they are passed directly for the triangle. You don't get. I'm not sure though. You don't get back in the 3D. You have to get back the points and calculate. So the hardware matrix that exists on 3DO will transform. You will project them on the CPU, and you will have to create your vector yourself from the point. So that's some extra work for the CPU, unfortunately. So the hardware doesn't accept vertices. It accepts these three vectors and the bitmap and a lot of other information. Okay. And I guess that's what I want to say with this thing, because yeah, you can kinda say that the hardware has an engine that takes a bitmap and can stretch it to create 2D sprites, but also can stretch it to map any arbitrary quad. So you can map the exact polygon areas that would come from a 3D engine in the final step. So it's wrong to say you start from there and go backwards to 3D. You have already done the 3D processing. You know the polygons. Yeah, and this, I have said that 10 times. This has cancelled the work to make it more dramatic. Okay. And I'm spreading that, hey, this is misleading. It's very easy. People think it's something so absurd, and that's why the Saturn failed. Because it was something so opposite from logic, something irrational for a 3D engine. Anyway, I don't know. I like few comments on. I like this comment because it even mentions. It's just like saying Doom isn't 3D. It is. Yes. Not many people. There is another reason. Why though? Because it's that. It just doesn't use what we now consider standard rendering world. It goes a way that you get some data structure and you project them to the screen, and then you have to fill it with 2D stuff. And if it's not polygons, in the case of Doom, it's vertical wall columns and these planes, horizontal lines. But it's we lock our minds to say this is 3D, this is 2.5D, this is the right way. Those were absurd ways, but people were experimenting. We might in the future reach new ways of doing 3D engine that will become standardized, and now we will be looking at the actual modern 3D engine and we will say that wasn't really 3D because now we are doing it in the right way. Maybe we calculate any atom in space and do some physical lighting thing on voxels or whatever. So yeah, I need to finish this video because I'm sperging. Actually,